Hey guys, welcome to our very first lesson in Algebra I Summer Prep. Let's get into our notes here. So the first thing we're going to look at today is something that you're probably already familiar with. It's called the order of operations. So we use the order of operations when we're simplifying an expression. And there's a very, very popular acronym that goes along with this, and it's something called Pemdas. I'm sure that looks familiar to you. Let's write it. I'm going to make this a little bit bigger, and let's do all caps here because this is an acronym. PEMDAS. PEMDAS. Okay, so this tells you, it helps you remember the order of operations when simplifying an expression. So the first thing you should look for is parentheses or any kind of grouping symbols. It could be brackets also, but we use the P for parentheses. Let's write that out. Parentheses. First thing we look for when simplifying an expression. Okay, the next thing we look for are exponents. E for exponents. And if you can't remember what that is, we'll look at it in a minute. Exponents. Okay, next part comes, now you might think M, multiplication, but actually the M and the D, multiplication and division, are grouped together. I almost want you to do this in PEMDAS. Put parentheses around those because they're grouped together. The M and the D are kind of interchangeable. And same with the A and the S if you want to group those together as well. So we'll put M/D right here and we'll say multiplication / division. But it doesn't mean multiplication has to come first, okay? When you look at the problem and you scan it from left to right, whatever operation you see first, whether it's multiplication or division, that one comes first. So you scan it from left to right. So let's just put in parentheses so we're really thorough here. Let's put left to right. Running out of room. That's okay. Okay, and then this is actually very similar for the last two. It's addition / subtraction. Let's write that out. Addition / subtraction. And same thing. It doesn't mean addition comes first or subtraction comes first necessarily. It's whatever you see first when looking at the problem from left to right. I'm going to go L to R for short. All right, so let's look at some examples here. Number one, keeping PEMDAS in mind. We know we first look for parentheses. There aren't any, so we skip to the next one. Next one is E for exponents. There's none of those either, okay? The exponents would be like the little numbers, right? If there happened to be like a squared right here or something like that. Okay, no exponents. So next, I know if I skim out here a little bit, it comes multiplication or division, whichever happens first when you look at the problem from left to right. Well, if we do that, we notice right here, division comes before multiplication. Okay, I skipped over the addition sign because that happens last in PEMDAS. So the next thing I would do would be this part, it'd be 54 divided by 3. So I would bring down my 7, and I'm okay if you don't know 54 divided by 3 off the top of your head. I'm totally fine for little computational things like this if you want to plug it into your calculator. So let's go ahead and write down the 7 and also our plus sign. And then 54 divided by 3 is going to give us 18. And then we still have our times 2 out to the side. Okay, so it's even a little bit more simplified now. Let's keep going with it. Next would be our multiplication. So we're going to do the 18 times 2 part next. So let's bring down the 7 plus, and then 18 times 2, that's going to give me 36. And then we just have one step left, and that's going to be to add 7 plus 36. That's the only thing we have left to do. We know addition comes last. That's going to give us 43. Final answer. Okay, great. Let's look at another one. Number 2. So we go through our little checklist of PEMDAS. We start with parentheses. There aren't any. We go to the next one. We do happen to have an exponent here. So if we skim through, we have this little 5 right here. So we know that takes precedent over everything else. So let's bring down our 17. I'm even going to bring down the minus sign. and it's just the 2 that's raised to the 5th power. Now be really careful that you don't do 2 times 5. That's not what that means. 2 to the 5th power actually means 2 times 2 times 2 times 2 times 2. 5 times, right? You take that thing, multiply it by itself 5 times. So you can either do 2 to the 5th power in your calculator, or you can do 2 times 2 times 2, etc., you know? So 2, let's put that in our calculator. 2 to the 5th power is going to give us 32. So we're going to fill that in next, 32. And then we bring the rest of the problem down. So divided by 4 and plus 6. I'll go ahead and erase this part. All right, so we did our exponents. What comes next in PEMDAS? Well, that's our multiplication and division. We've got a minus sign, a division sign, so we know that's going to come next. So we're going to take the 32 divided by 4. Or you could think of it as negative 32 divided by 4, okay? If we just look at it as 32 divided by 4, I would bring down the 17 and the minus sign, and 32 divided by 4 would give me 8. So 17 minus 8 plus 6. And now what do we have left here? Well, if you think of PEMDAS, after that comes addition and subtraction, but whichever one happens first when you look at it from left to right. So what I see that happens next is 17 minus 8. So if we do that first, that's going to give us 9. And then we'll bring down our plus 6. And then our last step is going to be add 9 and 6, so we get 15. Final answer. All right, let's try another one, number 3. And if you guys want to start trying these on your own, feel free to pause the video, fast forward a little bit, and then check your answer. All right, there's no parentheses. We do have an exponent, so let's go to that first. We're going to do 4 squared before anything else. So that's 4 times 4, which gives us 16. So let's bring down our 24. Minus 16 times the 3 plus 15. Okay, keep thinking about PEMDAS and what would happen next. So next after exponents is going to be multiply or divide, but we only have multiplication here. Okay, so we're going to do 16 times 3, and that is going to give us 48. So I'm going to bring down 24 minus 48 plus 15. And now all we have left is some subtraction and addition, and we're just going to go left to right here. Okay, now you got to be careful because we're going to get into some negative numbers now. All right, but if we do 24 minus 48, we're going to get negative 24. And then we've got our plus 15. And you just have to be mindful of your signs here. But if we add 15 to that, we're going to get negative 9. Okay, awesome. Let's try this last one. This is a little bit of a bonus one, okay? But if you want to try it, go for it, and let's see how you do. Okay, you've got a big fraction going on right here. What I recommend you do in problems like these is kind of look at the top as a separate problem from the bottom. So I would almost like ignore the bottom for now. It's easy for me to undo that. Maybe don't cross yours out, okay? But we're just gonna ignore the bottom part for now. And let's just simplify the top. So we do have parentheses and we have exponents. So let's look inside the parentheses first. And within the parentheses, I would do the exponents first. Okay, so I'll make this a little bit smaller. Let's come down here. So inside the parentheses, I'm gonna leave the 7. I'm gonna put minus, and then 2 squared is gonna give me 4. Close my parentheses, plus 17. I'm just going to keep working with this numerator. Now I would finish the parentheses part by doing 7 minus 4, because everything inside parentheses has to happen first. So that's just going to become 3. And once you have done everything, oops, dropped my mic. Once you've done everything inside the parentheses, you really don't need to write the parentheses anymore. Okay, so we're just going to write 3, drop the parentheses, and then add 17. Okay, so then that's going to give me 20. Now careful, that's not our final answer. That is just the numerator. All right, so let's go like this. I'm going to say that whole top thing simplifies down to 20. And I'm going to put that all over. Now I can uncover this bottom part. And let's look at what our first step would be down here below. Well, I do see multiplication here, so I know that comes before the addition. Let's go ahead and do 2 times 5 to get 10. So I'm going to write down negative 14 plus 10. Okay, zooming in here. Now we're just going to add negative 14 plus 10. That's going to give us negative 4. So now we've got 20 over negative 4. And now we can kind of like work with those together. So that just means 20 divided by negative 4, which ends up giving us negative 5. Final answer. All right, so that covers simplifying expressions, the whole Pemdas stuff. Let's go ahead and look at our next little topic here, which is going to be about combining like terms. I'm sure you worked with this last year also, so this should be a little bit of review for you. So notice this whole expression they give us up here. There's 2 types of terms that we have. We have terms that have an X on it, and then terms that are just like regular numbers, right? So we split them into 2 categories. We call them variable terms. Those are the terms with the variable. Variable just means your X or your Y. And then the constant terms, the terms without a variable. So those are just going to be your regular numbers. All right, so if we were going to list out our variable terms here, well, if we skim through, I can circle these actually. This would be a variable term. So let's write that one out, 7x. And we're just listing them, so I'm just going to put some commas. Careful, if you said 5x, you're halfway right, okay? Make sure you look at the sign in front of the term. This would technically be negative 5x. Okay, and then our last one would be 4x. And there's a plus sign in front of it. We just don't have to put a plus sign. It's implied that it's positive if I just write 4x. Okay, those are all of our variable terms. And then our constant terms would just be everything else in this one actually, right? You would have a positive 3, a positive 8, and negative 1. Okay, cool. Those are our 2 types of terms. Now this goes a little bit further just to go over some basic vocab so you don't forget this word. We have something called coefficients. All right, so the coefficient of a term is the number that's next to the variable. So our coefficients would be 7, negative 5, and 4. All right, so it's just the number that's right next to your variable. That's it. Just a little vocab lesson there. Okay, so let's do something with this now. So if we scroll down here, it says you can simplify an algebraic expression by combining like terms. So this is the same problem. Let's go ahead and combine like terms to simplify. So any of your variable terms can go together, so to speak, right? So let's do that. We've got a 7x basically minus a 5x, and let's just go in order. So think, what's 7x minus 5x? Well, that's 2x, okay? And then we have 2x plus 4x right here to give me a total of 6x, and that is how we combine like terms, okay? And then the other ones are just regular numbers that you're going to either add or subtract, right, depending on what their sign is. So we have a positive 3 plus 8, so that's 11, and then we're taking 11 and subtracting 1, so we get a positive 10. So I'm going to put plus 10 right here, and that would be fully simplified. Okay, so let's look on the other side now, and let's practice simplifying some expressions. If you'd like, go ahead and pause this and try these top 4, but we're going to go ahead and do them together if you want some help. Okay, so number 1, very simple. We have a 3x plus a 6x, which can combine to give me 9x. That's simple. Okay, you just got to remember the fact that they both have an x on them, it means they're like terms. It means we can combine them, but it doesn't mean we change that part of them. You're basically just adding the coefficients together. All right, number 2, 9a minus 10a. Be careful here because it's 9 minus 10, not the other way around. So this would be a negative 1a. Let me write that out, negative 1a. Or the more common way to write this would be to drop the 1. Don't drop the negative, but drop the 1 and just say negative a. We'll write it like that. Okay, number 3. Now be careful, you can't combine all of these. They're not all like terms, but we can do the 7m minus the 5m part. We can combine those and get 2m. And then we would bring down the minus 6. And actually, that's it. That's all we can do on that one. Fully simplified. Okay, and number 4, let's see. Let's kind of skim through. It looks like we've got some terms with x on them. Let's just look at those first. I've got a 5x, I've got a minus x, and I've got a 3x. So I can do 5x minus 1x. That's essentially what that is, right? So that would give me 4x, and then add the 3x to give me 7x. All right, let's see what else we have. And if it helps you, you can actually kind of scratch these out and be like, okay, I'm done with that one, and that one. And look what we have left, just a 7y plus a 2y, which we can combine to give me 9y. So 7x plus 9y, and we cannot add those together. They have what I call different last names, right? There's an x, there's a y, different last names, you can't combine them. That's it. Okay, our next section here, it looks a little crazy. It's very, very similar to what we just did, I will say. Just a little bit more, it's a little bit more complicated because we're involving exponents, but it's done the exact same way, y'all. So let's read through this. It says terms with the same exponents or combination of variables and exponents are considered like terms. When combined, be sure to not change their exponents. Okay, so let's look at number 5. We've got a 5x squared plus 7x squared. Well, we know we can combine those because they both have x squared on them. Okay, so I would say they have the same last name. Now be careful, you can add the 5 and the 7 together, right? Add their coefficients, so that would give us 12. And then you're gonna leave the x squared exactly the same. So 5x squared plus 7x squared is just 12x squared. That's it. So it looked complicated, but it's actually really easy. Okay, let's try number 6. Okay, so we got negative 15 into the 5th plus 4 into the 5th. They're both into the 5th, so we can combine them. So this would give us what? Negative 11 into the 5th. And that's it. Okay, let's try number 7. Now just scanning through, these are all c to the 3rd power terms, which means we can combine all of them, okay? So let's just go left to right because that's what Pemdas would have us do. So we're going to basically do 8 minus 7, which is just 1, plus 16, which gives us 17 c to the 3rd. We know we can just keep that last name the same on it. All right, last one here in this section. We've got some k squared terms, right? I can kind of underline those. I've got an 8k squared, and I also have a negative 2k squared, or you can think of that as just like an 8 minus 2 to give us 6k squared. Okay, and like I said, if it helps you, go like this. Be like, okay, done with those. What else do you see that we could combine? Well, we do have a k and a k right here. So be really careful with the signs though. This is like a negative 1k, and if it helps you, put that 1 in front. So a negative 1k minus 5k. So you're doing negative 1 minus 5. I see a lot of errors when it comes to problems like these, but that would combine to give you negative 6k. Okay, and then we also have our plus 7, which there's nothing we can combine with that, so we just put it on the end, and then that's it. That would be fully simplified. Can't combine any more terms there. All right, that covers that section. That takes us to the distributive property. We could probably breeze through these really fast. I'm sure you guys did this last year, so let's recap this. You'll notice parentheses everywhere, and you'll see a number on the outside of them. So if you see a problem like this, like on number 1, you're going to start by taking this number and distributing it, aka multiplying it by everything that's on the inside of the parentheses. So I'm going to take the 7 and I'm going to multiply it by x, which just gives me 7x. Don't overcomplicate it. 7 times x, 7x. That's it. Okay, and then we have a 7 times positive 4, which is 28, positive 28. So I put plus 28. And then I can't combine those because they're not like terms, so that's it. So maybe pause and try the rest of this section and then check and see if you get them right. So we're going to go through them real quick here. Number 2, we're going to distribute 2 to everything. 2 times b is 2b. 2 times negative 3 would be negative 6. So I write minus 6. Okay, number 3, I'm going to distribute negative 4 to y, which would be negative 4y. And then negative 4 times 3, which would give me negative 12. Okay, next one. Distributing negative 5, being mindful of the signs. Negative 5 times m is negative 5m. And then negative 5 times negative 2 would be a positive 10. Number 5, careful with this one. There's just a negative sign on the outside. You can think of that as a negative 1 if you'd rather do that. Or if you like to just think of it as a negative, you can do that too. But if you take a negative 1 times y or a negative times y, that just gives you negative y. It's really just going to change the sign of everything that's in the parentheses, but nothing more. Okay, so it's like now you've got a negative times a negative. So that's just going to make that a positive 9. Or you can think of it as like negative 1 times negative 9, which is positive 9. And that's it for that one. Last one here. Okay, we're going to distribute 8 to the 4. So that's going to give me 32. And then 8 times negative b, which would be negative 8b. So I write minus 8b. And that's it for distributing. Okay, this is a bonus section we're going to do here. Okay, so I really want you to feel confident on the rest of the problems. If you feel like you can do a little bit more and you want to challenge yourself, then here we go. So this is just going to combine everything that we just did, distributing and combining like terms all in one problem. So it says to simplify an expression means to ensure that there are no parentheses and no like terms. Let's dive in. So that's when we'll know we're done, when there's no parentheses left and there's no like terms left. All right, you can kind of follow like order of operations. We know that we're going to get rid of parentheses first, and we do that by distributing. So if you see parentheses, we're going to distribute first. So here we're doing 8 times 2x, which is going to give me 16x. And then I've got 8 times negative 3, which is going to give me negative 24. And after you distribute, that gets rid of the parentheses. So then I just bring down this minus 6x. All right, and now look at what you have left. Notice you can combine some like terms. I've got a 16x minus 6x to give me 10x. And I bring down my minus 24. And that's it. There's no like terms left, so I know I'm done. Okay, let's try number 2. This one's a little bit crazier because there's a couple sets of parentheses, but let's see if we can just take it one step at a time. All right, let's distribute 9 to everything. I'm going to do 9 times 2k to give me 18k. And then I've got 9 times negative 4 to give me negative 36. Okay, parentheses are done with that one, but I also have parentheses over here. Now, keep in mind there's a minus sign with the 2, so we're going to look at that as a negative 2. So now I'm doing negative 2 times 7k, which would give me negative 14k. And then I've got a negative 2 times negative 12 to give me positive 24. Okay, and now we're just combining like terms. So I notice I've got an 18k minus a 14k, which is going to give me just a positive 4k. And then we've got negative 36 plus a positive 24. So I know that's going to be a negative, what would that be? 12. There we go. All right, and then that would be fully simplified. Can't combine those. All right, we got 2 left here. Okay, looking through this one, I do have parentheses. I have a negative on the outside that I do need to distribute. If you want to put a negative 1 there to help you out, go for it. So I'm going to bring down my 10. And if I do negative 1 times y, that's just negative 1y, or just negative y. And I got negative 1 times negative 6, which would give me positive 6. and then I bring down this minus y. All right, combining like terms, I'm gonna look at the y's first. I have a negative y and another negative y. Careful with this. That's like -1 plus a -1 to give you -2y. So -2y. And then I just have 10 plus 6, so just plus 16. Okay, last problem. Here we go. It looks a little crazy, but I think we can do it. Okay, let's bring down our 6. And then we know we're going to have to distribute this 8 to everything first. So let's go ahead and do, and it's positive 8, so that's good. We got 8 times 4w, which is going to give me 32w. So I'm going to put plus because it's positive, plus 32w. And then I've got a positive 8 times a -7, which is going to give me a -56. So minus 56. All right, takes care of that one. Let's look over here. We do need to distribute this -1 to everything. So we got -1 times 2w to give us -2w. And then we got -1 times +1, which would be -1. All right, let's combine our like terms. I'm going to look at the w's first. So I've got a 32w minus 2w, which would just give me 30w. Okay, and now we've got 3 other numbers to combine, so let's be careful here. We have 6 minus 56, okay? So we know it's going to be negative. I'm going to put a minus sign. And you can actually kind of switch that and be like, well, what's 56 minus 6? That's 50, but just slap a negative on it. That's kind of how I think of those. So it's a -50. Oh, wait, we still have another one. I don't want to write it down yet. So it's a -50, and we also have -1. -50 minus 1. Well, that's like -50 plus -1 to give me -51. So minus 51, and we did it. Nice job, guys. That was a lot of math for our first lesson. Yeah, that was our first one. Okay, good job, you guys, and I'll see you on the practice sheet.